Please tell me that my screen is visible.
Yes, ma'am. Very good.
Okay. So, for today, our topic is Introduction to Linux. Okay. So, before we start this course, we should know about this Linux operating system. So, today we will understand what the Linux actually is and why it has so many distributions, or how it is built internally, and what is the filing system. Okay. So, everything we are going to see in this session. Firstly, what is the question is, what is Linux? As you can see, Linux is an operating system, and it is a software that sits between the physical computer and the program you run. Okay. While managing the memory, in between it manages memory and processing or storage, and you can say all the connected device. Okay, what is the working of an operating system? It manages everything while you run any application, or while you execute any program. In that, it manages that program as well as the other thing that is running in the background. Also, it manages the storage, it manages the connecting devices, it manages the processing, it manages the memory. Okay, so everything is managed by the operating system. So in a similar way, Linux is also an operating system, so it is also present in between your physical computer and your program, whatever you run. Okay. Also, what is written here, it is a open source Unix like operating system, kernel first released by Linus. This kernel was firstly released by Linus Torvalds in on September 17, 1991. Unlike proprietary operating system like Windows and Mac OS, Linux is developed collaboratively, allowing anyone to modify, distribute, and utilize its source code. Okay, the term open source itself defines that the source code is available to everyone. They can see their source code, they can use it and modify it according to them, and they can make a new source code and launch it into the market. Okay, so open source simply doesn't means that it is a free of cost. It means that the source code of the operating system is available to everyone. Okay. So it is free and open source, which means anyone can look at how it works, it or even you can improve it. Or Linux quietly powers a huge part of your digital world. Okay, most internet servers, almost your supercomputers, and even in Android phones, it runs on Linux foundation. Okay, on every exam where you go, wherever you go for CBT examination, so that examination is happening on the foundation of this Linux OS only. Okay, so it is silently playing a big role into our digital world. Also, what we can say is, we can compare this Linux operating system is just like a manager of a hotel. Okay, you can imagine it like a, if there is a hotel, there is a manager to manage everything. So operating system is just like that only. Okay, so in a similar way, Linux also works like that. Okay, but we cannot use the Linux operating system like a the original Linux operating system, that is not free, that is licensed. Okay, but the source code is open for Linux. That's why what happens, some companies or some organization has done what, they have taken the source code of the Linux, that means the main engine how Linux work. Okay, they have taken the source code of the Linux, and what they have done, they have set their own tools, they have added their own tools, they have added their designs and software, you can say they have added multiple softwares to that source code and release it as a complete or ready to use packages that we call as Linux distribution or distros. Okay, so each such package is called distribution, or you can also say distros in short. That's why we you have heard of Ubuntu, you have heard of this Red Hat, or Arc Linux, Kali Linux. Okay, so what are all these? These are not the Linux operating system. Instead, these are Linux distributions. Okay, because Linux is modular, developer bundles central Linux kernel with package managers. Okay, so they have taken the main engine or the main source code of the Linux, how Linux works, and they have added their own flavors to it. Okay, and then they have released the complete package into the market with the different names, so that we call it as Linux distributions. Okay, so we have different distributions, that is first Ubuntu, that we have seen yesterday, that we were installing to work on it. Okay, Ubuntu, Debian, Red Hat, Kali, okay, CentOS. We have so many distributions, like we cannot count, but these are some popular distributions that everybody uses. Okay, and each distribution has their own flavor, has their own property, has their own uh, like features. That's why they are available in the market. Okay, just like Ubuntu is the most beginner friendly distros, which is great for new learners, and uh, it is also good, it is like its interface, it is beginner friendly. Okay, and it has extensive community support, so that's why we were using Ubuntu, because it is very good for a new learner. Okay, and it is also high popular for both personal desktops and the corporate cloud servers. Okay, the other Linux is Linux Mint. Okay, I think you have heard of Linux Mint, which is designed to feel familiar to Windows user. Okay, Linux Mint is just similar to Windows users, just like we use in Windows. It is similar to Windows. Just next is Fedora, the other distros which is uh, popular between developers who want the newest tool. Okay, who want the newest tool first, they use Fedora. After that, Debian, this is extremely stable or often used as base for other distros. Okay, then CentOS, it is like um, it is used in large companies servers, for servers and stability for support, and it is also used by the security or like that this Kali is used for security and cyber security experts or testing team. Okay, this Kali dextros is used by cyber security experts or digital forensics. Okay, because these are good at hacking or providing securities. Okay, so these every distribution has its own features, that's why we use them as per our requirement. Whatever we want to do, the on that basis we choose our distribution, so where we have to work. Okay, so in a similar way, as per our course you have seen, we have chosen Ubuntu because it is user friendly, it is good for learning, beginner purpose. That's why we will use the Ubuntu Linux distribution. Okay, The next thing is Linux architecture. How Linux work. The internal architecture of Linux system operates in highly coordinated conceptual layers, moving from physical hardware to user facing application. Okay, so here in Linux architecture, as you can see, some of the layers are mentioned here. First is the hardware layer, then kernel space, then cell, then user space. So I think you have guessed that the most outer layer is user space, or sometimes you can also call it as application. Okay. So this is user space application, which you can see um, your user interface, the layer where user application or GUI and developer environment executes safely without interfering with core system ability. So basically this application layer is nothing but the GUI, whatever you see in the application. Okay. Then next we have, um, let me tell you the, okay, so here the most outer layer is application, then we have shell, then we have kernel. Okay, then we have hardware. Okay, so in this way, hardware, so in this way the architecture of Linux is aligned. Firstly the application, then we have shell, then we have kernel, and then the innermost layer is hardware. Okay, so as I have told you that application is nothing but the GUI, whatever you see on the screen, with that is the application layer. Next we will come to this kernel, which is the most important thing in the Linux. Okay, so what is this kernel? Kernel is basically a core component of Linux operating system. Okay, this is a core component of your Linux operating system, and it is between your hardware and the application, or you can say user space. This manages system resources. It ensures that you have smooth communication between the software and hardware. It will also control how processes are executed, how they are scheduled, and also isolated to maintain system stability and security. Okay, so kernel is responsible for many things. Let me write here and I'll also tell you. Kernel is responsible for, let me list down what are the things the kernel is responsible for. So very first thing is memory management. Okay, so memory management, inside the memory management, what happens, it allocates or manages the system memory efficiently. Okay, what memory should be provided to what process, everything is done by this kernel space. So kernel is also responsible for the memory management. The second point is process management. Process management is what? So to schedule any process, and it also controls the execution. If some processes are in queues, so which process has to be sent to the processor to execute, these all things are managed by this kernel space. Okay, so everything about the process management is done by the kernel space. The next thing is resource allocation. What is resource allocation? It means that how to distribute the resources among the devices, among the among cpu, among how to distribute cpu to any process, how to distribute memory to any process, how to allocate input output devices to the process. Okay, so everything, this resource allocation is also done by the kernel space. Next thing is the device management. Okay, so device management means how to control the hardware devices through device drivers. Okay, this is also this is also the work of kernel space to manage how devices are controlled. Okay, then we have
Ma'am,
another
can you repeat again memory management and process management?
memory
For
management means simply that how to allocate or manage the system memory efficiently, that how much memory uh, for any process to for execution of any process, it should be loaded into the memory, na? It should be loaded into the ram. So which process is to be the first to be loaded into the memory. Okay, and how much space is given to that particular space, particular process. Okay, so all these things are managed by the uh, kernel. Okay, also,
Contiguous and non-contiguous memory, na ma'am?
yes, just it is very similar to the work of operating system. Okay, whatever we study, I think in the
okay,
school
ma'am,
also
got it,
we
ma'am.
study,
Yeah,
in
yeah.
the school also we study na, what is the work of operating system. All these work in the linux is done by this kernel space. That's why I have told you this is the most important or core component of this architecture. Okay, okay, the next was application interaction. So how interaction, okay, I think I made a mistake. Interaction, okay, yes. So how the application and the hardware is communicating, the interaction between them is also managed by this kernel space. That means, like I am currently using this word, then how my hardware knows that I am using currently this word application to uh, write this notes or write this notes. Okay, so this interaction is also managed by the kernel space. Then security. Okay, the next thing is security. So enforcing access control or system level security mechanism, all these things are done by this kernel space. Okay, so these are some responsibilities of the kernel that I have told you, which is done by the kernel. Okay, then see, we have different types of kernels also. Like we have monolithic kernel, we have micro kernel, then exokernel, hybrid kernel. There are four types of kernel also. Okay, so let me write the name here as it is not given in the notes. So types of kernel. Okay, so the very first thing is monolithic kernel. Okay, second is microkernel. So we have different types of kernel: exokernel, then we have hybrid kernel. Okay, so these are the four types of kernel which is available. Then first is monolithic. So what does monolithic kernel do? It offers you the high performance due to direct communication between your component, but the kernel size makes it like more complex and it is harder to maintain. Okay, this monolithic kernel is offers you the high performance, but also due to the large kernel size, it makes it more complex and harder to maintain. Okay, so all core operating system, you can say, services such as we have studied, process management, memory management, device drivers, file system, or everything is run in this monolithic kernel space. Okay, and also we are using this Ubuntu. This also uses this monolithic kernel. Okay, then microkernel, the second type of kernel is microkernel. So this is only this kernel is responsible for, it provides you the essential services like process scheduling, memory management, uh, while other services are executed in the user space. Okay, that means microkernel does some of the job only, like process management or memory management, but other jobs of the kernel was done by the user space. Okay, so it does uh, some of the jobs only. Okay, but microkernel provides better security and modularity. Okay, but there may be, you have to compromise with performance here. Okay, so every kernel has also their ability and features. In a similar way, we have exokernel. So what about exokernel? Exokernel exposes hardware resources directly to the application. Okay, so it allows them to manage resources at low level. Okay, so user can directly interact with the hardware. With using this exokernel, user can directly interact with the hardware. So it gives you like high flexibility, high performance, because you are managing everything. So they there will be high flexibility and there will be great performance. Okay, but increases application complexity due to minimal abstraction provided by the kernel. Okay, so it has high complexity. Okay, then we have hybrid kernel. So hybrid kernel, as the name suggests, is combine the features of monolithic and micro kernel architecture. Okay, so these are some types of kernel. At least we should know the name, that's why I have told you here. Okay, the next thing is shell. What is shell? I think in most commonly we use this name shell. Can anybody tell what is this shell?
Ma'am, basically it's a command line interface, ma'am.
It's a command line interface. Okay. Any other answer? Okay. The basically shell is a software. Okay. What is this? It is a software interface to the kernel. You can't see kernel, but shell is that interface, or shell is that software which provides the interface to the kernel. Okay, and it takes command from the user. You type your command into the shell, and from it takes command from user and interprets them or executes them. Okay, the say or also you can say the shell transmits these commands to the kernel, and then kernel performs the requested operation. Whatever you type the command, that operation is like a request to the kernel, so it will execute that operation. Okay, user can just enter any command onto this shell, and kernel will function that command in a similar way, whatever you have asked for. Okay, so we have different types of shell. Okay, let me ask you one question. What is the difference between the shell and the terminal? Is they both are same thing or different?
So Shell is the is like a programming okay application.
Hmm.
Okay, like a Python. So
Hmm.
what we do in Python? So in Python we write the code, okay, and which we run. So according to that, the interpreter will uh, compile that code,
Hmm.
interpret that code.
Hmm.
So as an interpreter, like interpreter, it is a working, and we are writing the Python code. So that is called the shell scripting.
Hmm.
So we write the scripting.
Hmm.
So in the uh, CLI, okay.
Hmm.
So you have asked the question like two things. One is uh, kernel capabilities like
No, I
shell.
have asked shell versus
Yes.
terminal. Okay. My
So
Kernel.
question
shell
was
takes
this.
only
Yes,
Shell
yes. So
text
versus
kernel
command.
is the user interface in which we write all the code and everything and run all the commands. That's it. And shell will run that command and
hmm.
script.
Okay, okay, yes. ठीक है. Okay. The terminal is basically the program that is open into the window so that you can type your command. Okay. It gives you the space where you type your commands. Okay. So terminal is nothing but it is a like it you can say a window or a program which allows you to type commands. Okay. So it's just like a you can say it's like a TV screen. Okay. Or the shell is what it is a program which run inside the terminal and that actually reads your command. Okay. And then pass it to the kernel. Okay. Understand, these two things are different. Mostly we commonly we use shell and terminal for the same purpose, but these two things are different. Okay. So terminal is like physical speaker box, or you can say a physical box, or shell is like something present inside that box. Okay. That executes your command, that takes your command or takes your request whatever you type in that window. Okay. And we have different types of shell. Can you name some shell, whatever you know?
And PowerShell, Bash.
Hmm. Yes.
And CSH
Yes.
Bourne shell.
Bourne shell, bash, na. Bourne
and
shell, sh,
ZSH.
zsh, csh. Okay. Corn shell, ksh, bash, born again shell. Okay. Z shell, zsh. Okay. Fish, friendly interactive shell. So we have so many shell that is used to execute our commands whatever we give to the whatever we type onto the terminal. Okay. So the default shell in the ubuntu is bash. Okay. So which is also called born again shell. Okay. That's good. Okay, let me move on to this last thing. This is hardware layer. Okay. So this is a physical component. Hardware layer is nothing but the physical component that includes cpu, ram, storage devices, and other input output devices. And this is you can say the lowest level of the architecture of linux operating system, and where all components uh, come to the one place and execute our request. Okay. And it is also you can say it provides you like low level controls and allows system to function efficiently and reliably. Okay. So here the hardware is basically where actually our uh, command or instructions are executed. Okay. So we have seen all these four layers of the Linux architecture: application, shell, kernel, and the hardware. Okay. Next, kernel versus shell. So what is the difference between kernel versus kernel and shell? Shell is
Ma'am,
also executing and
ma'am, one
kernel is
talks to
also
the user
executing.
and one talks to the hardware. Shell talks to the user and kernel talks to the hardware.
Yes, yes. Okay. So kernel act as like engine room or a brain of your computer. It allocates memory, is it can schedule say a CPU task, it can control device drivers, it can do many other tasks whatever an OS do. But shell will actually only interact with the, it's like a user interface between the terminal and the kernel. Okay, it takes the request and pass it to the kernel, and kernel is responsible for executing the command. Okay, so these both terms are not similar, they are very different things. Okay, next we will see the Linux file hierarchy system. Okay, so Linux file hierarchy system is what it defines the directory structure or the directory contents in Unix like operating system. As we have seen that Linux is inspired by the Unix, that's why whatever structured is present in the Unix, in a similar way we also have same hierarchy in the Linux also. Okay. In the Linux file hierarchy system, all files directories appear under the root directory. So in the Windows you have seen, compare, if you compare to Windows, we have C drive. Okay, which is the parent directory. In a similar way, in the Linux, this backslash is the main root directory. Okay, we will see this in a practical way also, but in tomorrow's class. Today we will see only the theoretical section. Okay, but you can see, I am telling you the Windows equivalent so that you can imagine it like that. Okay, so just like in Windows we have C drive as the main directory, in a similar way in Linux we have slash. Okay, either you can say slash or backslash, whatever you say. This single slash is a root directory. Okay, here you can see under this root directory we have so many directories or files present inside this. Okay, so in a similar way, just like in the C directory, here let me show you this PC. Okay, this PC, we have this main directory local disk C, and inside this we have so many directories present inside this, and within this directory we have so many files. Just like that hierarchy, just like this, we have here also the root directory is represented by this this slash. Okay, so it follows like hierarchical tree structure. Okay, making like navigation simple and logical. And here we have different directories like slash home directory, slash etc, slash bin, as you can see the name given here. Okay, home directory, bin directory, boot, dev, etc. Okay, so we have different directories present inside this root which serve a specific system purposes. Okay, they serve some specific system purposes. Okay, and Linux also supports multiple file system like extension ext4, xfs. We have different types of file system here. Okay. Hmm, let me show you this. Okay, here you can see this bin directory. Okay, this bin, that is binary. Okay, which is equivalent to Windows system 32. Okay, what is present inside this bin? Here essential commands, like whatever we type the commands inside the Linux, just like ls command, we have pwd command, we have so many different types of command that is present. And so their executable files are present in this bin directory. Okay, their executable files, or you can say the logic behind or the code behind these commands was uh, these commands was present in this bin directory. Okay, so this is like it contains binary executable, or you can say common Linux command you are using on the terminal. And you can also see this directory, I will show you tomorrow. Okay, then next we have another directory, that is boot. This boot, okay, this is system reserved or boot files. Okay, so this basically stores all the files that is required for the booting of the system. Okay, it includes like grub bootloader configuration, essential kernel files. Okay, these all are present in this boot, and while booting it loaded all the required files during the startup. Okay, so it is equivalent to like system reserved or boot files present in the Windows. Then we have dev slash dev, that means device files. Okay, the Linux also store .dev directory, which is special files that act as an interface between your hardware and software. Okay, so device files are like are of two types, that is block devices. Okay, block devices, for example, like hard drives, or other is the character devices, just like your microphone, speakers. Okay, so these are like devices uh, whose execution, whose you can say like it is it is like a interface between these special file, act as an interface between your hardware and the software. Okay, and these also include the terminal devices also, like USB or any other devices that is attached to your system. Okay, then we have etc file. Okay, etc, this is for system configuration. Okay, this is also a short name for editable text configuration. Here you can see this is also a short name for editable text configuration. So it contains all configuration files for the system application or users or services or any type of tool that it contains. Okay, so here we have like system wide configuration, whatever configuration is needed, everything is stored in this slash etc file. Okay, for example, let's say if you have like user details, okay, user ID, local addresses, all these things are stored in this etc file. Okay, it also contains like startup and shutdown shell scripts also. And yes, next is home directory. So this is the most common directory we always interact with. Okay, so every like non-root user, okay, who non-root user has their personal directory inside this slash home. That's why I written here slash home and slash user, whatever the username you will provide, that username will appear here. Okay, so just like in C we have C users, and inside that username is present, the name folder contains the username. Okay, so in a similar way here inside the slash home every non-root user gets a directory with the name of the with the name same as you write in the username. Okay, so each user can create, delete or modify the files in their home directory, and access of another user's home directory depends on your security configuration. Normally you cannot access the another user's home directory. Okay, so home directory for all users is just to store their personal files containing like saved files, personal settings, etc. Okay, then we have lib library. Okay, this is a shared library. So like application, some of applications requires like shared libraries to run, so that libraries will be stored in this lib file. Okay, so these include like dynamic libraries that are needed during the runtime. For example, like Apache server libraries are available here. Okay, next we have media. So in Windows, just like we have drive letters like DE, after the C we name the drives as D, E, F, G, H. In a similar way, here slash media represents what? This slash media represents like devices like USB, CDs or pen drives that are mounted under your media. Okay, so for example, let's say when a like CD is inserted inside CD is inserted in into the system, then the details will appear like temporary mount directory for a removable device. Okay, so that all the information will be present inside this slash media. Okay, so it will appear like slash media slash CD-ROM or slash USB or anything, whatever device you insert into your system, that all the information will appear in this slash media. Then we have slash mnt, that means mounted drives. Okay, so these are temporary drive mounting. We have like external drives that are connected, or sometimes we temporarily mount any devices that appears in this slash mnt. Okay, this is where like your content become accessible to the system. Okay, it is like temporary mount directory where system admins can mount any file system and that is accessible to your system. Then we have opt slash opt. These are optional software. Okay, now you can say that third party software or packages that are not part of your default system or installation, that is stored in this slash opt. Okay, so if you have any add-on application, so you can add in the details will be saved in this slash opt file. Okay, slash opt directory, sorry. Then we have sbin. Sbin was written here. Okay, so it is admin level system tools. This directory basically holds the administrative binary files like firewall management tool, okay, init, routing, IP tables, or binary files that are used for system that are used for used for primarily used for like system primarily used by, you can say, as system administration, that typically requires the root privileges. If you have root privileges, then only you can execute these or execute these resources. Okay, just like we have slash bin or slash sbin, they both contain the binary executables. Okay, but this is totally admin level system tools, but these are some essential common tools. Okay, so here in this sbin you will see that IP tables, reboot, fdisk, IP config, these type of files or these type of informations will be stored here. But in the bin we have like common tools or common commands whatever we use in daily basis, or whatever like list of commands whatever is present in the Linux, that all files will be present in this bin. Okay, then we have slash srv. Is there present? No. Okay, we have one more directory, that is slash srv, that is site specific data. Okay, so it is served by the system such as like data or script for web servers. So data offered by like ftp servers or repository version control system, they all serve they all the information that is given by this scripts are stored in this srv. Okay, so srv basically stands for service only. Okay, it contains like server specific services, that is related data. Or for example, like um, like you are running any script into the web server, so the whatever servers is required or whatever the service is required to run the servers is stored in this srv. Okay, and then the last is tmp. Okay, tmp, that means temporary. Okay, tmp, that is temporary files. Okay, so program creates some temporary files while you execute any program. So in between maybe there is a necessity of creating some temporary files during execution, so these will be stored in this slash tmp. Or in the windows you will find c colons c and then temp. Okay, so in the windows also you find this temporary files here. So these are basically and these temporary files are not created by is also created by the users and by the system also. Okay, then these two are left. Let's These are user. Okay, usr. So this is like read only user data. Okay, it contains like majority of user utilities or applications whatever you use on a daily basis. That data is stored, that applications is stored in this user bin. Okay, so it
Ma'am,
contains binary
hello.
files. Yes.
Ma'am, we use these commands to show, it will be show in the Linux, oh sorry, on the
Yes,
operating system.
yes, I'll show you tomorrow. Today I'm
Okay,
just taking the theoretical lecture. Tomorrow I'll show you all these directories where it is present. Okay,
okay, ma'am.
yes. So these directories are basically present in the root. Okay, because what we are seeing, what I have told you in this diagram, see the root directory. Within this root directory all these directories are present, which stores the essential information for the like for all the operating system. Okay, so bin file, that's why I'm telling you that which uh, which directory stores what information. Okay, so I'll show you tomorrow in the practical session. Okay, so what I was telling, okay, user bin. So here we basically stores the applications. It stores the application that you use on a daily basis. Okay, or it also contains binaries, libraries, documents, and source code for second level program. Okay, then last is proc. Okay, so what is this proc? As you can see, the Windows equivalent of this proc is task manager or system information. So using this seeing this proc, it contains the running process information. Okay, that means whatever processes are running inside your system, that each process has some unique id, or it all every information about that process will be stored in this directory, that is slash proc. For example, like if you have like I am running this word This is also an application and it creates a process. Okay, when you will see in the task manager, it will show you that Windows is running. Okay, so it has some unique process ID. Okay, then if any application like uses some libraries or some dependencies, that will also be present in this. Everything about the process will be present in this slash proc. Okay, so this is all about the Linux file hierarchy system. So I have tried to show you the Windows equivalent so that you can easily understand the Linux files hierarchy system, because most of us use Windows. So that's why I think this comparison will help you to understand better this file hierarchy. And also, when you use Linux system, you will already understand these all hierarchy. Okay, so this time maybe it is like boring, or it will be like a very big hierarchy or something. But once you will use all these, once you will like use the Linux operating system, you will find that all these things are like easy, just like we use in Windows in a similar way. Next thing is the terminal basics. The terminal basics is the desktop window wrapping the text-based command shell interface, and where whenever you open a terminal, what you find, something is written like this. Okay, the prompt looks like this, where the username is written, at the host name is written, then we have tilde sign and the dollar sign. After that, you type any command. Okay, this this is the way, in a way, your prompt will look like. Okay, the structure of prompt, what it provides, so basically the username, the current user who is logged in with what account, that username will be appear here. Then the host name, the name assigned to your machine or cloud instance, that will appear here. The tilde sign is the shortcut character signifying that user is currently located inside home directory. Okay, so this tilde sign is basically signifying that what is the currently located, that you are currently located inside the home directory. The dollar sign indicates regular user privileges, that means administrative root access displays hash marker instead. But if you are non-root user, then it will show you dollar symbol. But if you are using the administrative root access, it will show you the hash. Okay, so this is simply a basic thing about the terminal. Okay, then next we have some common Linux commands that we use on daily basis. The very first command is ls, then we have ls-la. Okay, I think I have completed the content in 1 hour, so let's just give me 2 minutes, so I will show you all these things, all these directory into the practical. Okay, on the Linux, just give me 2 minutes. Is my screen visible?
Yes, ma'am, it's visible.
Okay, okay. Okay, so I have Ubuntu here in this VMware workstation that we have seen yesterday. Just it will take a bit time.
Try to close this session and open the new one.
So you have to keep patience
Uh,
throughout this course
Close this
because
session.
these things will take some time. Okay.
Then you can close this session and open the new one. It will run uh, faster.
Okay, I have tried the power on and power off.
No, no, not this one. This Ubuntu 64 2-bit. There is one
I
clause.
have done Nitesh. I have done. I have powered off and I have powered on also.
No, close tab. Yesterday also I have facing the same thing. Yes. Close this and then run.
Actually, you can see this system is hang. That's why it is not working.
Okay, okay.
Just please wait. Okay, that's why I have told you. You guys please have patience because throughout this course you will find these type of errors. You will have to wait for some processes. Okay, so don't be in a rush. In this course, you have to keep patience. अरे ओपन हो गया था.
Man, is this class is over?
Now it will
No,
run in
I'm
some time.
just showing you the all the files that I have told you in the file hierarchy system, and I will tell you some common commands also. Okay, so it is booting. Just it will take few minutes. Just please wait. I will tell you when the class will be over. I have opened it earlier, but
Maybe this take the time because after also facing this kind of problem.
yes, it takes time. Actually, in our office, the exam is also going on, so internet is also a bit slow. Okay, and as you know, this will take internet. Of course, without internet, it will not work. So this may also be a reason. Okay. So here is the window that we were waiting so far, and this is the terminal. Okay, so here this is, as I have told you, the basics, that is the username. Here it is given, then the name, virtual platform Nilet LKO, and this dollar symbol, that means I am a non-root user here. Okay, now let me show you the first command, that is ls, which is basically means listing. Okay, so I think I am in a root. Now it is good. Okay, now it is non-root user. Before it was showing slash. Okay, so now the ls command, as you can see, desktop, downloads, pictures, templates, snaps, documents, music. Okay, all these folders are present in this home directory. Currently I am present in which directory? So if you want to know you are present in which directory, then you will type pwd command. Okay, so pwd command will let you know in which directory you are currently present, that is slash home and the username. That means I am into my home directory. Okay, home directory is just for this Nilet user. Okay, Nilet LKO. This is the name of the user that I am using currently, and I am present within this directory. And within this directory, what are all the files or folders present is can be seen by ls command. By using this ls command, you can see whatever files and folders are present in this directory. So desktop, downloads, and all these folders are present, and we have one file also. These blue symbols are showing that these are directories, and this is like file. Okay, so while.sh.save, this is a file. Okay, but you will ask, like, whatever I have told you, the files, that is slash bin slash etc, that are not present here, because this is those are not available for non-root user. Okay, there I think I have told you these all are present in the hierarchy of root directory only. Okay, but currently I am not a root. How you will switch to root? So the basic thing is, if you want to switch to root, you can use sudo -i. There are so many commands to switch to the root, but I am telling you the very beginner friendly command, which is sudo-i. Okay, it will ask you the current user password. Okay, current user password means the user I am currently using, that password it will ask. See, sudo authenticate, it is asking me the password. I am typing the password here and enter. So now you can see this has been changed. Earlier it was showing Nilet LKO, but now it is showing what? Root. Okay, also I have told you, when you will be a root user, it will not show you the dollar symbol, instead it will show you the hash symbol. Okay, so now you got it. Like here I am present inside this root user. Okay, so now I am the most powerful user inside this system, in this operating system. Okay, now from here I can do
Ma'am,
anything. I can,
root is the administrator.
yeah, root is an administrator here. Okay, so what I was telling, yes, so inside this root, now we will see what are the files and directories present. So how we can see, before that let me use the pwd command also. So using this pwd, I think you can see that, just please wait a minute. Okay, so now you can see you are present in the root directory. Okay, so for the non root user, what is the name of home directory? Slash home slash the username. Okay, the home directory is present inside the home directory and with the name of username. Okay, but for the root, what is the home directory? This slash root is the home directory for the root user. Okay, can you see the difference? Is this okay?
Yes, ma'am.
Okay, now let's have ls command. So ls is showing what? Snap only. I have used cd slash. Okay, what does this mean? Change directory. I want to change the current directory and I want to switch to the root. As using this sudo command, I have changed the user. I have switched to the root user, but the directory was still like I was using a temporary directory. I was not present inside the slash. Okay, this slash I have told you in the diagram, this is the root directory. Okay, which is represented by a single slash. Okay, now let's do ls, and now you can see whatever I have told you, all these directories are present inside this: bin directory, boot directory, etc, lib, okay, mnt for mounting, proc for the application, run, okay, temporary for the temporary file, variable, user, sys, everything. Okay, so all these directories are present in this ls, like in this root directory. Okay, so now you have seen all this. So in this each directory there is some information, whatever I have told you, I have described you what informations they hold. Okay, so just like bin directory, I have told you they have commands. Okay, they have commands. So let me show you the cd bin. Okay, not cd bin, cd bin. Let me use the cat command. Okay, no, cd wins ls. Okay, yes, so these are the commands that we have. So it is a very big list, as you can see. Okay, and inside this list even ls command will also be there. If you see, then ls command will also be present inside this, or cd command will also be present inside this, whatever command we have used there. Let me show you. uh, See this cd command. Okay, cd I have used cd slash. Okay, so the cd command is present, that means the executable files are present. How these commands work, how these commands will work, the logic behind these commands is written inside this bin. Okay, in a similar way, like ls. So instead of searching like this, I can use another command, that is ls grep. Okay, so it will filter ls. Sorry, let me write it from start. ls grep cd. Okay.
No, ma'am.
Okay, I have
GB.
written the wrong spelling. grep. Okay, so all the cd related commands or files is present here. Okay, in a similar way, if I want to search for ls, see, all these files are present. Okay, related to ls, like this ls, we are using ls command, so this file is present here. So how this ls is working, which is this is written inside this file. Okay, so now I think you have got it, how this directories directories are working. Okay, and if you want to come out of this bin directory, if you are present inside any directory and you want to come out of that directory, the command is cd space dot dot. Okay, so now you will see the difference here. Now I am into the root directory. Now if I will write ls, you will again see the files and folders that we have seen earlier. Okay, so we have seen some commands like ls, cd, okay, pwd. These are some basic commands that we will use for regularly on a daily basis. Okay, now if you want to log out from this root user, okay, so how you will log out from this root user? Just you can type either exit, either you can type log out. You will come out of this root user and you will be again a non-root user login. Okay, so here again you can use this terminal. Now you are no more a root user, you are a non-root user. Okay, so I think this is enough for today. Tomorrow we will see some more commands and some more Linux essentials command, then file management, process management. We will see each and every command related to all these whatever I have shown you in the kernel, that is related to file management, related to process management, related to networking. All day by day we will see the commands related to these all these things. Okay,
Ma'am, how to copy the data from CD drive from this one? How
how
to
to
copy
copy?
to how to data from CD drive to an hard drive?
Use cp command.
No, no, CD command is not used. This different command used, like, ma'am. Hello,
Yes, yes, I am hearing.
ma'am. How to copy the data from some CD
Huh.
source to CD to in hard drive?
We will see in next lecture. Okay,
Okay,
will next in next lecture I will show you how to copy a command, copy some content from one file to another. Okay,
okay.
yes,
Thank you.
thank you.